All right, hello everyone. Welcome to ECS CDM12 Media Computation. Today we're going to be talking about conditionals and animation. But before we get started, let's cover some logistics. So we have lab today in Cruise, just like last time. I now have the alarm code for the lab, so we should be able to use that with much less fuss. So please bring your computers. The lab is designed to help you to facilitate your learning in variables, in particular in this case. You can see the lab 2 file inside of the course materials. So I've been putting code examples in there. Well, now there's a lab directory which has the lab 2 file, the lab 2 folder or processing project with a folder that contains a test image, just like lab 1, and the PDE file. There's also a zip file in there too, so you can just download it and unzip it in your own directory, and you can have that, take it as a zip and deliver it as a zip, metaphor complete, flow complete. It is worth 1% of your grade, so please join us, have some fun. It's designed to take between 5 and 25 minutes of your time, so there's plenty of time to either ask a basic, or not basic, but questions that you have about processing in general, or working on assignment 1. We've had a few questions on assignment 1. There's been some information that I posted in Discord about it. Please join and converse with your fellows. It is assignment 1 is due Wednesday. Note that there is sort of like a questions blackout period for this course, 24 hours before things are due. So I will be having office hours today, and I may have some ad hoc office hours tonight. So please take advantage of that where you can. You can read the policy in the syllabus about why we are taking this approach. And this is something that I haven't tried before, but I'm very interested in, like the equity and equality implicit in, or I guess explained by, this 24-hour blackout policy. Questions? I see tentative hands. Yes. Was that a question or? Okay. All right, that's fine. That's fine. I'm happy to take questions at any time, as always. All right. Conditionals and animation. So now we're going to get started. We're going to pull back another layer of computation. I'm going to give you another power, another tool. This tool is really core to what makes processing, what makes computation, what makes programming powerful. Anybody care to venture what that could be based off the word conditionals? Yes?
If-then statements.
If-then statements. But I ask you why? I'm being indecisive, which is part of the answer. Yeah, exactly. You control when something happens based off or based on a set of factors, a set of conditions. This gives us the ability to make decisions. If something is the case, do this thing. If something is not the case, do something else. We can now have branching or conditional execution in our programs. Right? So this is pretty cool, right? Here you can start really catering your application, your processing, your code to what's going on. Instead of just simply changing colors over time, you can now have that change be reactive to mouse input, to other variables. And we'll be digging into how this works and cashing out a bit of it in animation. Oops. I can't control the slides through the projector window. So this is bouncing off of Shiftman. Chapter 5. So this is the associated text. How have you been finding the reading so far? Good. I think it's a pretty clear and approachable explanation of what's been going on. How many of you have been doing the reading and are all caught up through chapter 5? Okay, all right. Looks like you have some homework to do. I decided not to give pop quizzes on the homework because you're all adults, so please do the work. It'll be fun. You'll learn stuff. Should I take the left path or the right path? Conditionals allow you to make choice on what to do based on data. An example of this is student feedback. So if I were to write a very simple student feedback program basically, if you get an A, I will tell you great job. If you get an F, I'll say maybe you should spend more time at the library. More time at the library for you. Then how would we accomplish this? Right now, without conditionals, with what you've learned so far, we can't actually do this. We don't know how to make a decision based off a grade value. But that grade value is data. It's in a box, right? We could have a float grade value, which is a number between, that we want to look at the numbers between like 100 and 0, and then we want to look at that value and put it into the grade buckets, right? A, B, C, D, F. For some reason we ignore E. Tier lists love this, right? Now, to do that, we have to look at the bucket. We have to examine the value in the bucket and compare it to our grade ranges, right? 90 plus A, 80 to 89.9 B, 70 to 70.9 C, etc., right? So grade is data, and it's and we want to the response to it, saying great job or more time library for you, is an action associated with that data. This is what we call branching. So the code branches or does something different based on the decisions you make. In this case, your grade. Here's an example of what conditions do. So conditions are very specific things in programming. You'll use them in very specific ways in very specific places. And we call these Boolean conditions. Remember the Booleans? Those are the true or false values, the zeros or ones that say value is true or value is false. They're core to this. All of your conditions will actually turn into a true or false value. For example, grade being greater than 90. Alligator wants to eat the big number. So grade greater than sign 90. If you look at that, and if the grade is actually greater than 90, it will return true. It will become true. It will be interpreted as true, I should say. If grade is like below 90, that statement is false. It will be evaluated as false. Same as grade greater than 40. So these conditions are often, but not necessarily, based on data. And we use the command if to perform a conditional, right? So here's the basic structure at the bottom. I hope your phone's okay. If condition, block of code. Now you can take this grade greater than 90 and put it into this condition. So first off, I want to disambiguate this angle bracket, condition angle bracket. That is just a bit of communication we're doing in class. That's not actually code. You can't run that. But we want to, you can think of it as a template, like in Mad Libs. It's a blank to fill in. You want to fill in angle bracket, condition, angle bracket with a statement that returns true or false, a conditional. So you could plop grade greater than 90 right inside of there. You could delete the angle bracket. You could delete all of this value inside the parentheses and replace it with grade greater than 90, and you'd have a conditional. And if grade is greater than 90, you would run the code in the block denoted by the curly braces under the if. Right, just like we have those curly braces with draw and setup that show the code that you would actually execute, the commands you'd execute between draw and setup, between those in that region. Same thing with conditionals. If the condition is true, you'll run the code. If that condition isn't true, you'll bypass it completely and just move right on past it. Does that make sense so far? All right, I want to make sure we're on strong footing here. Now, these conditions, as we said, must evaluate to true or false. And I forgot, the slides are on Canvas. I didn't send an announcement, so if you want to follow along with slides, they are there. There's also examples that we'll be going through, caching out what all of this means in the examples in the course materials folder, examples folder in the course materials folder under day 4. So here are some types of Boolean, some types of comparators, some little operators, some keywords that will allow us to perform these true or false checks. Double equals means two values are equal to each other. Are two numbers the same? So this is not the assignment operator like we were talking about before, right? Since that would put the value on the right-hand side into a box on the left-hand side. This is checking the left-hand side and the right-hand side to see if they're the same. Greater than, we just discussed. Greater than or equal to. Less than or equal to. Basic math comparison operators. Little checks. Here's an example. Here's how you can output text to the bottom of your processing window. This is great for checking values and making sure things are progressing as you think they should be in your code. So here, you can output text using printline, the printline command. So what that does is it prints a line of text that actually ends the line, and the next text you put out will be at the beginning of the next line. So it's a very handy little function. And it takes text, or a string. It can also take number values in there as well and convert them to text. There's an implicit conversion that that processing knows how to do between the basic types like integers and floats. It'll know how to put those into text automatically, as we'll see here. So int f equals 4, float y equals 7.2. So we were making two boxes, one called f, one called y. F is the value of 4, y is the value of 47.2. Print line some text, so that will actually display some text. And this is a PowerPoint thing. Those should be not, if you put this into processing, you'll see that those quotes are now straight quotes, meaning that there's no leftness or rightness to them. They're just a double quote. But when you have fancy text editors like things like Microsoft products, you'll see that they do like the left quote, the heavy part is on the bottom, on the right quote, the heavy part's on the top. That won't be the case in your code. So that will print some text in a line at the bottom. Yes?
I'm sorry, can you be more specific about what LM is?
Yes, it will print a line of text to the bottom of your processing window under your code. Normally where you see errors and things, it'll print text right at the bottom. And we'll take a look at that in class today. We'll have some examples that'll show that off. So it's printing a line of text. You have a question?
That is good.
Excellent. All right. So next, we look at the fourth line in this code sample. Print line f. So this prints the value stored in f, and I forgot to make that comment gray. I'll take care of that later. So what this will do is instead of printing some text in its own line, we'll print the value 4 and move on to another line. And then finally, we have something more complicated. Print the value of f is space plus f plus, and then the string and y is space plus y. This is taking a bunch of values together and making one big string out of it. Because processing knows how to take an integer and turn it into text, it knows how to take a floating point value and turn it into text, you can all use this together. And so that means the plus operator doesn't mean addition in like the math sense. What it means is, hey, smush these two string values together, these two text values, and make them into one text value. So you'll have the value of f is, and then you'll see this as it'll interpret everything between the quotes as one text chunk. And then it wants to add this text chunk to it, f, so it'll interpret f as the character 4 and slap that in there. And then after it makes this chunk, it'll look at the next addition. So, okay, everything that was here, the value of f is 4, it'll smush that together with and y is. So after you perform this plus, you'll have the value of f is 4 and y is, and then you'll have this last plus, which will smush the y on there as well. So you have the value of f is 4 and y is 47.2. Yes.
You explained this already, but can you re-explain the difference between int and float?
Yeah, int is what we consider a number, right? It's a negative 4, it's a plus 5. It's something without a decimal.
Integer.
Yeah, it's an integer, classically written, right? And floats are more like real values in math. They have decimal points.
Gotcha. Thank you.
You're welcome. They can also be negative. Yes.
Which part of text or which part of the code would this get going? Like setup or in draw or?
Usually this is in draw,
Okay.
right? If you want to like see how a value is changing over time, you're getting some like weirdness in your animation or weirdness in how something changes over time or weirdness of a color, you just print line that out in your code as a diagnostic and see what the value is over time at the bottom. That's like most of debugging that you do in processing. There are some fancy debugging tools that we'll talk about, but this is like your first line of defense. All right, questions on this? This is particularly important when you're making decisions because printing lets you record the decisions as they're being made. Yes?
Int and floats, those, like, both of them count as text, right?
The processing knows how to turn them into text. Here's some conditional text output. Here's our example from earlier. We have int grade equals 75, and we want to see if grade is greater than 90, then run this block of code. Print line, awesome, you got an A. Very positive. So what would this print?
We print anything because the condition is not that.
Exactly. Grade is 70. That is not greater than or equal to 90. So we'd skip this block of code altogether and just move right past it. But if we made grade equal 75, then that block of code would be ran, and at the bottom of our screen, we'd have awesome, you got an A, printed. So we're going to use this in some examples. Let's talk about mouse input, just briefly. So processing gives you some variables that it fills as a mouse location that you can just use. They're called mouse X and mouse Y. And you can use these in expressions. You just use them as you would any other variable you've declared. The trick is that processing is actually declaring this variable for you. It's defining a box and a label, mouse X and mouse Y, and it's filling the box with the right information all the time. It's not something you see, it's something that processing does for you. And you can just use these boxes as you want. You can read those values and respond to them in your conditionals, or print them out, whatever you need. You can make your own custom mouse cursor by putting mouse X and mouse Y, like drawing something like a square or a star or something, and having its X and Y location be the mouse X and Y location. So you can use these in expressions. So we can trigger actions based off mouse input. So if we have our two variables, W and H, if our mouse X is greater than half of W, we can draw a rectangle, which is starting on half W and 0. So the middle of, so 200 and 0 is the top left coordinate, and then it will have 200 width and 400 height. This is how you find the center of a screen. So if your center of screen, if your screen size or your size is 400 by 400, that width divided by 2 is the vertical divider right down the middle, right? And h divided by 2 or height divided by 2 would be the vertical or the horizontal line dividing it in the middle. Let's take a look at some code. Come on, processing. You can do this. All right. This is the mouse conditional example, which I will show you in a moment. There we are. Right, and so in this mouse conditional example, we have a size 600 and 600. We have W and H declared above, so just slightly bigger than the example in the slides. We have draw. We make a background, and we just want to draw some dividing lines. Right, so this is how we're making a line first, vertically, or first we're doing the vertical line, then we're doing the horizontal line. Then we're doing a simple mouse check, right? If mouse X is greater than W divided by 2, meaning it's on the right side of your window, then we want to draw a rectangle, a red rectangle for that right side. Let's run it. Oh, there we go. Cool. All right, so now we have our 2 dividing lines to show the quadrants, right? I'm moving on this side, nothing's happening. I move on this side, red. Nothing. Red. And I should really change this. I'm not going to do that again. You can look at it on your own. I realized that red is an epilepsy color. This was not my example that I made. I will fix this before I send it out to you. So I don't want a large high contrast red flashing on a big display. So please, actually, let me just change that real quick. Let's instead go for a darker blue. No, that's a high contrast color. Let's go for a lighter blue. 200, 200, 255. This should be a little less contrast. There we go, a little violet. Right? Any questions on that? Yes.
The mouse X and mouse Y depends on like after you run the code, like where you have that.
Yeah, that's being constantly updated as your code's being ran. Every time draw is called, mouse X and mouse Y will have updated values. You're welcome. So what we're doing is we're having a different behavior on, we can actually have a different behavior on true and false. We can have a conditional, and then this is a new keyword for us to use, else. So if your condition is true, run that first block of code. If it is false, or not true, run code inside the else block. Right? This is where you can take, now we have a branch where you can take one path or another path. Before, what we had is you could optionally take a fork, optionally take a detour, and then go back to the main line. That was if you just have an if, you optionally can do a thing and then go back to the line of execution. Now we can do one thing or another, and both of them will then go back to normal execution. So we have a left and a right path to take, a true or a false path. Welcome, have a seat. You can check multiple conditions. So there's if, and else. So we will only run that first block if the first condition is true. And then we'll skip everything else in this else if else construct. Now, if condition 1 is false and condition 2 is true, then we'll run the code in this second block. if condition 1 is false and condition 2 is false, we will run what's in else. All right, so now you can start making some more complex decisions. Let's go back to our example. Yeah, welcome. Come on in. Have a seat. You may want to, at this point, open up the slides and check out the earlier things that you missed, because we've been over quite a bit. So let's take a look at what we're doing here. So I'm going to get rid of this old code that ran. And so what I did here is I selected multiple lines, and then I hit Control or Command / which made comment block, which made the comment in front of everything I had selected. A handy little thing to do. Now, what we're doing here is we're having a more complex check. So we're still drawing our 2 lines that turn the space into quadrants. And now we have an if, an else if, an else if, and then an else. So now our first check is mouse x greater than w divided by 2, and is mouse y greater than h divided by 2? Yes.
Do you want to change the colors before you run the code?
Oh, are they? There's okay. So yes, this is. Thank you. Let's see. Well, I think this is the only red one. Thank you for reminding me. I appreciate that. And I'll share a tool with you all. There's actually a very handy tool out there that will take whatever window you have on your computer and check it for visual, for like epilepsy, or other sort of visual indicator harms. It's a handy little application. I've been running it quite a bit. It's free, open source. All right. So mouse greater than w divided by 2. Right, so this one, what do you think this one does? Mouse is greater, so we have our line. I guess we still have this open. Mouse is greater than, that is the OBS window. There we are. Mouse is greater than the width, so we're on the right side. And h and mouse x or mouse y is greater than h divided by 2. So it's below the center line, right? So that to me looks like the bottom right quadrant there. Quadrant. And we're filling a rectangle there. And that rectangle starts at w divided by 2, h divided by 2. So that's the right smack in the middle. And then it is half the screen wide and half the screen tall. So we're making a rectangle in that bottom right. Okay, now we have if mouse x is greater than w divided by 2. Right, so we know at this point that this conditional is not true. But this one's slightly different. It starts the same, right? It still has mouse greater than w divided by 2, but doesn't have this mouse y greater than h divided by 2. What do you think this does? Top right. Well done. So what we know is that together these aren't true, but this individually could be true. So here we have an explicit, like, we know that mouse y greater than h divided by 2 is not true here if mouse x greater than w divided by 2 evaluates to true in this case. Then we have a similar deal with mouse y, h divided by 2. And then finally, if all those conditions fail, we draw on the top left. So this gets the bottom right. This draws on the top right. This draws on the bottom left. And this draws on top left. Let's run this. All right. Top left. Bottom left. Bottom right. Top right. So now we can tell which quadrant we're in. Any questions on this? Yes.
Just double check.
They're the buckets we defined.
Okay, there it is.
Yeah,
Okay.
it's at the very top. They just happen to correspond with the size you set the window. And notice this here, you can't actually use variables to make the size of the window for some system limitation that I haven't figured out yet. Yes.
Doesn't processing have preset variables for width and height that are just width and height?
I'll have to check. I'll find an answer on that for you. It very well might. So this explicitly is controlling it. Maybe you can change it through those. I'll have to see. Good question. All right. So now, whoops, back to presentation. Now, we have more nuance in what we can do. We have an extra power. Now we can do our grading example. So if our grade is 75, what will be printed? Give you all a moment to figure this out before I pick a hand. I see you first. I'll call on you first. Wait, hang on. Let's let people figure it out real quick. Yeah, just give me a moment. Just like to see the wheels turn a little bit. Okay, what do you think?
So what kind of you got to see in this room?
It would print.
No. Wait.
Are you thinking?
No, that's what it.
Yeah, you were correct. Right, so let's follow this through. So if grade is 75, our first conditional is grade greater than or equal to 90. That is false. So we'll skip this first block. Then we'll go into this else if. Grade greater than or equal to 80. Well, grade is 75, which is not greater than or equal to 80, so we'll skip this. Now we go here. If grade is greater than or equal to 70, so grade is 75, which is greater than or equal to 70, we'll run this block, which is print line you gotta see. Then, because we had one of these conditionals being true, and we execute this line of code, we will then skip this else and continue on with whatever's below it. What about this? What will this print? Give you a moment to read this. If you can read and understand this readily, you're in good shape on conditionals. I see a tentative hand. Let's give it another second. 1, then 2. Wait, 3. I'm waiting just a moment for people to figure it out, then I'll call on you. 4. Okay, so we got some people figured out. Raise your hand if you think you are ready for an answer. Raise your hand if you just want a moment more. Raise your hand if you didn't raise your hand before. Okay, fine, I'll stop talking. Yes, what do you think?
Well, now that I'm looking at it again, would it still say you got a B because 94 is greater than or equal to?
It is, right? In fact, you can never ever reach this block of code. Right? Because everything that's greater than 90 will also be greater than 80. So that first conditional will always happen in that case when grade is greater than 90 and will never actually go to the next block. So the order that you put your conditionals in matters. Yes.
So the if condition takes priority over all the else's?
They're just ran in order. And the first one that gets ran is all that gets ran.
If always comes first, and then that one always gets.
Yep. First one checked. There we go. First one checked. Second one checked. Third one checked. If none of the things became true, run what's in else. Right. Any other questions on this? Order matters. All right, and if clause only proceeds, so basically this is reiterating what we had just learned. Order of conditions matter. The first true condition will be executed. The block of code associated with that if statement will be executed. And the final else is executed if all conditions are false. So this is a good little slide to consult if you get confused about how these work. Now we have some more things to use. So we have logical operators as well as math operators. So the math, we're like comparing values on the left hand and right side, like is the grade greater than 70? Well, now we can start comparing true and false values as well. So we have an OR operator. So those of you who have taken like a philosophy class or any other predicate logic, this is very close to that. We have the two vertical bars. So the shift of the backslash. Two of those together means OR. Right? So that means either the left-hand side, if either the left-hand side or the right-hand side around the OR expression, if either of those are true, then it collapses into true. If both are true, it's also true. If both are false, it is false. Then we have AND. That means both the left-hand side and the right-hand side have to be true for it to be true. If there's a false anywhere in it, it will return false. And finally, we have NOT. So this is different. This goes right before a value, and it flips it from true to false or from false to true. Right? So if you simply have a statement that's exclamation mark false, it returns true. It evaluates to true. And these will be handy as we go forward. Here's an abstract example. If A is greater than B and A is greater than C, we know then that A is greater than B and C. If A is greater than B or A is greater than C, we know that A is greater than B or A is greater than C. Or both can be true. And here's how we use the NOT. If A is greater than B, that will return true, and then you flip it. So if A is greater than B, this will actually return false. Right, and what we'll know from this is that A is less than or equal to B. This is getting a little bit nuanced. These are abstract examples for your understanding. Once you put these into practice, it'll be a little more meaningful. Yes?
Does that also mean it's false conditions will become true?
Yes. Flips both ways. Just toggles it. True becomes false, false becomes true. Flips the meaning of conditional. Right, so we looked at the more complex mouse example earlier, but just to reiterate, here we have a bunch of conditionals, and here's where those come together. So if mouse X is greater than W equals 2, and mouse Y is greater than H divided by 2, both those have to be true for this entire expression to be considered true. Right? So without this logical expression, we wouldn't actually be able to draw all the quadrants. So here we need a little bit of logic to help us out. A little bit of Boolean logic. A little bit of manipulating and comparing true and false values, not just numbers. You can have if statements inside of if statements. If A is greater than B, and if A is greater than 100, A is bigger than B and bigger than 100. That means you get an A+. Right? So, if this is true, we'll run whatever's in this code block. That can be any command that processing has. Virtually any command. Conditionals are no exception. All right, let's look at a little bit of animation. Let's cache this out. Animation creates the illusion of movement. Rapidly shows slight change in still frames. right? So this is like making a flip book or quickly, scrolling through, cell on film cells. It relies on the persistence of vision. And I think we'll have time to cover the mechanisms behind that in the eye. But basically, if the frames flip faster than the human mind's ability to perceive a scene, then it looks like it's continuous motion. Realizing this persistence of vision. You can animate any parameter of our objects: their color, their size, their position, their rotation, their stroke and fill. Let's take a look. At the weird wiggle box. All right, so this code here has something called max corner radius, top left corner, top right corner, bottom left corner. These are actually values in radians. And we have this dr value, which is how much the radians will change the current radian change value. All right, so we're setting our fill color to a dark, predominantly green. Size of window is 800 by 800. In our draw, we're just simply making this dr value bigger as we go, setting the background, but we're using rectangle. And actually, we're using the version of rectangle that has 8 parameters. So A and B are as you expect, top left, top right. C and D are the width and height. And then TL, TR, BR, BL, that's the radius of the rounded corners for each corner. Top left corner, top right corner, bottom right corner, bottom left corner. And so what we're doing is we're taking the max corner radius, that value that's 180, and we're multiplying it by this expression. So here with top left corner in radians starts out as 0, then 7, then 1.4, then 2.1. All those are these values, and we're simply adding this dr value to it. So what we're doing is we're progressing that radian 0.5 every frame. Then we're taking the sine of it because we want this to be a smooth animation. So a sine wave, starts at 0, goes up through 1, goes down to -1, back up to 0, and then repeats. It does that over the value from 0 to 2 pi. And if it goes above 2 pi, it's like starting at 0 again. So it's going around the circle. If you unwrap the circle and skewed it out over a line, it's basic sine. I'm assuming most of you have had trigonometry at this point. Well, what we don't want is actual negative values in this, so we want the absolute value. So instead of having something that goes like this, we want something that goes like this. Any thoughts of what's going to happen here? We're wiggling the corners. Kind of fun. To me, it's a little gross. I don't know what about it. It's a little slimy. The time I was resurrected is this. So let's see what happens if those values go negative. So I'm going to take the top left corner and remove the absolute value. So the sign, instead of being always a value between 0 and 1, will go down to -1 as well. Top left corner. Right, so that sort of like breaks the if you give that the radius value of those last 4 parameters to rect, if you get a negative value, it kind of freaks out. So it's drawing the radius of the corner inverted. Yeah?
So just so I can check my understanding, all of those max corner radius stuff below the command to draw a rectangle, those are all part of the same line, sort of. It's just that you hit enter over and over so you don't have to scroll left and right.
Exactly, yeah. Because that'd be a really long line. Right, so here, this is a case where we actually want to split, if you have something that's this long and this complicated, having it all in one line is very hard to read. So this is where you can actually do a little bit of favor for yourself and spread the larger parameters and put them all in one line each.
What happens if you control T?
It stays the same.
Oh.
It kind of recognizes this as a use case. And normal, like, you want to keep your lines below 80 characters. So if you have a very long function call, you can do this sort of thing. And this is like we're saying, hey, we're indenting the parameter list inside of rect a bit. That's not a new code block. That's just a visual indicator that these are related. Yes?
Do you have to remember the sign and all that, like, codes right now?
No, you don't. This is just a fun little example that you can read on your own to understand. All right. Whoops, I popped out of this one moment. Where did we get to? We got to all the way down here. Oops. All right. So what we did is we were changing the corner radius, which is also something you can animate. Now, how do we drive motion? Well, you can use the global clock. There's a set of functions about time and how time progresses. Date and time inside of processing. So you can use that to your advantage, and we'll get to that. We'll talk about frames today. We'll talk about the actual time and delta time like game engines use later. So you can calculate parameters based on a global clock. So what we use here is a global variable that you increment each time you call draw. So this is a frame counter. So if we have our float frame count equals 0 at the top, we have a box with 0 in it. Well, how do we manage that box? How do we make that into a thing that counts up the number of frames that we've passed so far? Well, we put that inside the draw command. Whoops, pardon me. We increment the timer. So frame count equals frame count plus 1.0. Right, that's pretty handy. So just to be clear, that starts at 0. Once you run that fourth line of code, this line of code once, you'll have the 0. And we want to put a new value into frame count. So what do? Well, we look up its value, 0, add 1 to it. So now this expression here, this bit of code, is 1. And that's what we put in the box. The next time we go through, frame count will have 1 in it already. And so what do? Well, we want to put a new value into the box. So we have 1 plus 1 is 2. Put it into the box. This is what we call incrementing. And then we want to use that value in a command. What do you think this does? No guesses? I'll show you. Sorry? Go ahead, just say. Yeah, exactly. Is this the correct example? Sure. No, wait, there's a different one I want, pardon me. So this example will be the line following example. No, I'm sorry, this is the animation example. Where we simply move boxes around. Let's actually, forgot to comment this out. Right, let's see what we're doing here. So we have a frame counter. On our update, set the fill call in the background. No, this needs to be Control T. There we go. what we do is we increment our frame counter just like we saw on the slides. So every time we call draw, it gets one value higher, and we print it out. So you can see the numbers at the bottom here. These are the value of our frame count. Now what we do here is we draw a rect with the top left side being frame count. I'm sorry, the left being frame count, the top being 100, and we make it 20 wide, 60 tall. And we draw a second rectangle that's moving at double frame count. Its top is at 200, and it's also 20 wide and 60 tall. And every time our frame count gets greater than or equal to 400, we reset it. Right. So looking at this, you'll see this number down here. As soon as it hits 400, all the rectangles will go back to the left position. 400. Right? So the first rectangle is moving exactly at frame count. So once it gets to the right side of the screen, or 400, this value of frame count will become 0, and so it'll move back to the left. Now frame count times 2 is moving double, right? So it will, when the frame count is 300, it'll be at X value 600, which is off the screen, which will start being off the screen. So anything that's above 300, I'm sorry, it's 400 wide, I'm sorry. Everything that's above 200, it'll be off the screen to the right. All right. Presentation. So that's the basics of how to use a frame counter to do basic movement animations based off a count. Now you can do different operations to counter, right? You can rotate 2 times frame count, or rotate like 2 degrees every frame count, or 2 radians. 2 radians would be a lot, but 2 degrees every frame is pretty reasonable. A slow roll. So, what about this? This is basically what we had before, right? This is the example we just showed, where the rectangle 1 is moving twice as fast as the other based off rect count. Now, what if you wanted to change speed over time? Right? The acceleration was 1, or was it static at 1 in this case? Like it would be going 1, or the velocity, the acceleration is actually 0. The velocity is 1, so it travels 1. Travels 1 every frame. Now, let's say we wanted to actually have it go a little farther on frame 2 than it did on frame 1, a little farther on frame 3 than it did on frame 2. So that's acceleration. Its speed is actually increasing over time. Well, here you can actually take the increment that you go forward and multiply it by something a little bigger than what it was before. So it's getting 2% of last frame's acceleration bonus every frame. And then you can you use time acceleration to update your position values. Right, so here's one. Let's see, so if we you can copy and paste this in and you'll see that the rectangle just goes faster to the left over time. Let's see if I actually have a sketch for this. Yeah, I'll show it off in a sec. So velocity versus acceleration, right? Velocity is how much it moves right now. Acceleration is how much that value is changing over time. So how can you change the behavior at a certain point in time? Well, an if clause, you can vary the behavior based on the value of the count. So this is the example that we showed with the rectangles, right? So if the frame count goes above or below a certain value, you can change its behavior. In this case, if a rect frame count, if the frame count is less than 150, it'll be drawn lower, or I'm sorry, higher in this case if it's not less than 150. No, I'm sorry, negative would be up. It would go lower if it's less than 150, higher if it's greater than 150 in this case. I'll not confuse myself and then confuse you in the process. My apologies. Okay, so little understanding quiz. We want to rotate this rectangle. But what does it rotate around? Where's the pivot point? Do you think this will be a rectangle just spinning? Any guesses? All right. I'm sorry, go ahead.
Since the CNT plus one each time, it's going to be rotate by 1 degree.
Yeah, it'll rotate by 1 degree each time. What is it rotating around? The middle of the box, the top left of the box? It's actually the top left of the window. When you rotate, it's rotating around the origin, right? It's like if you had your piece of paper that had 0, 0, you're like putting a pin in that 0, 0 location and rotating it around that pin. This is why we use the transformations, right? This is why you would do the translate to the middle of the box, then rotate it. So it'll rotate around the middle of the box. So if you want something to rotate around its center, you have to translate it to the center. You have to translate transform. All right, use the translate call and put the shift the origin to the middle of the object you want to rotate, to the pivot point that you want to rotate around. So this is why push matrix and pop matrix are kind of handy. So pivot is around the origin. If an object to spin, move the origin, then draw the object centered on that origin. Something that'll be handy for you. Here's an example. Right? So here, we have the count going up. Pardon me, there should be a int count equals 0 or at the top. Void draw, count plus equals 1. Our rect mode is center. We're pushing our matrix and we're translating to 400, 400, which in this case would be the middle of our window. It's 800 by 800 window. Then we're rotating it around count as degrees, turning that degrees into radian value and passing that radian value to rotate. And then we're drawing the rect at 0, 0, so at our translated origin. And this does what you'd think. We actually added a line in the example so you could see it rotating, since it's hard just to see a dark circle rotating. But this would actually rotate 1 degree per frame around this pivot point, which is right in the middle of 400, 400. All right. Now, if you want to have things rotate, you have things changing over time, you could actually make a movie about it. So what processing does is gives you the ability, take care, gives you the ability to save a TIFF file, an image file, every frame. And you can save those into frames, and this uses the same syntax that clicking to save an image does, basically the same utility. So taking a look at that, let me find the example. This is the speed change example. One moment, I'll bring it up. Speed change. So notice what we're doing is we're drawing a few things, rotating a few things. You can look at the ellipse and pop matrix here. You'll see what's going in just a moment. What I want to show you is at the bottom, frame count less than 10. We can set that higher. This is just in the Google Drive folder. So we'll get the first 10 frames of animation out of this, which I'll show to you. If I have this set at 300, all of you would be like potentially downloading, or Google Drive would be uploading 300, like 1 megabyte images or so. It's not a very compressed format. Here's what it looks like. Oops. There we go. Hit the correct number. Oh, sorry. Let's change the size. Background. Where do we put this? Where do we put this? Here we go. right, so what we're doing is we're drawing ellipses of various colors and then having them spin. Let me change that red color, I'm sorry. Red. 30. Change these colors around a little bit. 300.
Isn't that going to change the position of the color?
Oh, you're right, you're right. I was changing. Thank you. Fill. Okay, well, that'll do it for now. Good eye. Oh, geez, okay, it is a darker red now, so maybe that'll be a little better. But now you can see what's going on. Let's just get rid of this red altogether. Pardon me. Red. There we are. Right, and so what we're doing is we have this increment value here that we're increasing over time. And what that's doing is it makes it's increasing the acceleration of the spin. So as frame count goes up, the spin will go faster and faster until our increment is greater than 60, and then we set it back to 1, which resets our acceleration. And if you look inside the frames folder where you ran this, you'll see that there are a bunch of TIFF images that are the sequential frames for the first 10 frames. Great, so once you have this, oops, I should turn this back to presentation. Once you have this, you can make a movie. So there's actually a movie maker tool in processing. So if you go to Tools, Movie Maker, you can drag and drop a folder with all your frames in it, and it will make a movie file with all of your frames in order for you. And it'll make a QuickTime movie file. Very simple format. But useful nonetheless. Make your own animations, make your own movies. There's an alternative option. You can save the frames like we did, you see in the example. And you can use a third-party program. QuickTime, Adobe Premiere, Final Cut Pro, FFmpeg. All these can take frames of animation and generate a movie for you. Okay, we went over a lot today. We went over conditionals. We went over mouse input. We went over animation. We gave a lot of code examples. Do you have any questions? Yes.
So you showed us like a keyboard shortcut to make a section of your coding into like comments, right? Is there an inverse for that? If you
Do
want
it
to add
again.
back in?
Yeah, if anything has a comment in front of it, it'll strip the comment. If you use command front slash or that's on Mac. If you use control front slash on Windows, it'll do the same thing. Yes.
I just have a question about the lab. Is it going to be due at the end of the lab today instead of on Friday?
Yeah.
Gotcha.
And it should be available for you to see in 12 minutes. Wait, maybe I said it's at 12:10. It'll be ready at the beginning of the lab for you. And you could already see the code anyway. No big deal. Yeah.
The examples with the rectangle and right now with the shape spinning.
Yeah.
When you have like the acceleration, instead of having to just stop and then reset back to 1, to get it to like decelerate, I guess, would you do the same thing, which is like time decel, and then when it reaches your certain value that you want, and just do like a minus increment, so like it would start decelerating?
Exactly. And you would usually there's a value that you can put in that will be like a -1 or a 1, which is direction of acceleration. Okay. So if the acceleration goes high in a positive direction, meaning that value is 1 instead of -1, once it hits a certain threshold, what you can do is change the acceleration to be negative value, so it'll start counting down instead of counting up. So you put that negative value in front of like the 0.01. Actually, you'd probably have to change it. So you'd want to maybe have two values, acceleration values. One could be 1.02 and the other could be like 0.98. And so when you decelerate, you go 0.98, which will decrease it a little bit. every frame. And then once that gets to the low value that you want to switch, go back to the 0.12 value. So just 2 conditionals added in there. Should do that for you. Yes.
For assignment 1, for the second one, was it supposed to be on the same page? Were the two images supposed to be on the same page?
On the same window. Yeah. You should make the image that you save should look exactly like the one given in the assignment. Yes?
Could you show us like the code for the rotating ellipse again?
Yeah, absolutely. So there's a lot here. I didn't want to go over this entire chunk of code. This is in the Google Drive, so you can actually see this. You have this available to you. It's in the Google Drive course materials. It's in the day 3. Is that true? No, day 4. It's called Speed Change, is the name of the folder.
Are they still rotating like in the original window or like?
This is why we do a bunch of push matrix and pop matrix with translates and rotates. So what we're doing is we're changing the origin, in this case to be at 300, 450. We're rotating it based off the acceleration that we're building up. And we're drawing that ellipse at the new origin, 0, just a little to the below that first origin. Then we're popping. Right, I guess let's start at the top. Let's start at the top. Right. First we're translating 150, 150. And then we are drawing an ellipse at 150, 150. We're popping it. So now we're back, the origin's back to 0, 0 instead of 150, 150. Now we're doing our second one with a new speed, the second speed value. Now we're translating it to 450, 150. The origin is now 450, 150, and we're drawing the ellipse there. We're popping it, so now origin's back to 0, 0. And we're doing the same thing for this third spinning object. Cool? You want to see another push-pop example? All right, let's take a look at something else. This will be the chartreuse collection example. So first what we have are 6 different shades based off chartreuse. And you can see their color values here. We do our normal setup, no fill. So we're not actually filling in the ellipses, but we're drawing their stroke weight, which is 16. So pretty fat stroke weight, pretty thick. The size of the window is 800 by 800. And first we're setting the background to the shade 6. So this color, the darker of the chartreuse line. And we're translating to 400, 400. So we're putting the origin right in the middle of the screen. Then we push that matrix. Then we're scaling the entire thing down. We're scaling, we're keeping the X size the same, but we're squishing the Y by 0.6. And then we're pushing that. And then we're scaling it by 0.6 again. So we're 0.6 on top of that previous 0.6. We do it again and again. So now we've squished it 1, 2, 3, 4 times. And then we're drawing an ellipse of shade 1 at 0, 0, 600 wide, 400 tall. Then we're popping that. So we're unsquishing by 1 level. Drawing the shade 2, also with the same ellipse parameters. Unsquish it 1 more time. Draw it with shade 3, same ellipse, same parameters. Then shade 4, then finally shade 5. And we're back to our original least popped stack, our original location. Great. What do you think this will do? Yeah, it's a little hard to describe, right? We'll have a set of squished, unfilled, chartreusey ellipses. Like this. Great. So the first one that we draw is unsquished. So first off, shade 6 background. Squish, push, squish, push, squish, push, squish, push. Set to shade 1, which is the lightest color, almost white. And then we draw that first ellipse. Right? Let's draw on the squished one. We'll pop it by 1. So it's unsquished by 1. And we draw shade 2, which is the lighter green, lighter chartreuse. And we pop again. So we unsquish by 1 more. And we draw shade 3, which is the actual chartreuse. Then we unpop 1 more. We unsquish 1 more by doing pop matrix. And we go to shade 3, which is slightly darker. Then we pop 1 more time. I'm sorry, shade 1, 2, 3, 4, and then finally shade 5. And then we draw the ellipse unsquished in shade 5. So what I wanted to do, why I made this example, was first I wanted to use a little, basic color theory for you. So something that looks a little prettier than the examples we've had so far. I'm a fan of colors. I'm sure many of you are as well. And I wanted to give you an example which showed like the power of push and pop in like just a very straightforward way, without being a toy exam. Does this make sense? Do you have any questions about this? Any questions? Not about this. All right. Then I think we'll give us a few extra minutes to get over and to get set up for the lab. And Arpreet, I think I saw you taking attendance. You took attendance, correct? Head count, thank you. Yes, sorry. That's a much more compressed value. All right, everyone. I'll see you over in Cruise in just a few minutes.